To tackle some simple extrudes, we're going to look at question 5 part B from the 2019 question paper. From the working drawing here, you can see that basically we've got two cylinders, a cuboid on the end of that, and then we're going to have to extrude to subtract some material to get the sort of groove in that sort of thicker end of the object. So to do this, I'm going to start with the larger cylindrical area at the top. So I'm going to start a sketch on any work plane, doesn't matter which, and I'm going to start by drawing the outside diameter of this object, which is 20 millimeters. Okay, so then we're finishing the sketch and we're using extrude to extrude that to a height of 10 millimeters. I'm then going to start a new sketch on this top surface. Draw a cylinder from the centre of that part again, and this time with a diameter of 10 millimeters, and then I'm going to extrude that to a height of 35. Okay, now I'm going to start a sketch on the top of that section again, and this time it is a rectangular shape that we're drawing. It is 2 millimeters by 6 millimeters, and then is obviously centered on that part, so we need to use the dimension tool here just to get that into the right position. Finish the sketch and then extrude that to 10 millimeters. So that's all been simple, straightforward extrudes to add. What we need to do now is use extrude to subtract to remove the material in this section here. So I'm going to start a sketch on that surface. I'm going to need to draw two circles here. The first one being the same diameter as the vertical protrusion, and then I need to do a second one with a diameter of 16. So then finishing that sketch and extruding to subtract that circle there. Now you can see there that it's just picking up the sort of intermediate ring there. So it's not doing this one, it's not doing the one in the middle, just the one in between, and we are subtracting that material 8 millimeters. That's that component finished using extrude. To look at something slightly different with extrude using work planes, we're looking at question 1G from the 2017 National 5 paper. As you can see here from the working drawing, it's basically two cylinders, but we've got this angled cut going through the larger part of the cylinder. So to tackle this question, I'm going to start by just doing a sketch again on any surface, doesn't matter which, and start with the smaller cylinder here. So it's diameter of 10 and has a height of 5. On top of that, I'll start another sketch and do another circle, this time with a diameter of 20, and then extrude that to a height of 50. So now we're ready to put the angled cut onto this, and to do that we need to identify a work plane that goes vertically through the object here. So I'm going to expand my origin and find a work plane that goes all the way through. So I could either use the XY plane here, or I could use the YZ plane. It doesn't matter which. So I've got this one selected, I'm just going to do this one. I'm going to start a sketch on this surface and then pan so that I can see the whole thing. Now, what you want to be able to do at this point is see through the object, or see into the centre of it, so you know where you're measuring and marking from. So I'm going to push F7 on the keyboard, and you can see that it has removed everything in front of that work plane, so that I can see into the surface that I'm drawing on. I'm then going to project the geometry of that shape so that I've got something to work from. Now, what you can see here is that we've got the line going from the centre down to a height. Now, I can't immediately put that in with the dimensions I have available to me. I don't know the angle and I don't know the length of the line at the angle. So I'm just going to draw it to somewhere on that line, but I don't want to get that green dot because I know it's not halfway, it's 30 millimeters down to the point there, and then 20 beyond that. So I know I don't want it in the centre. If I draw it to there, I can't move the dimension. So anywhere on that line, and at this point, I'm also going to draw a line from here to the corner and from the corner to there. The reason I'm doing that is I then get a closed profile, triangular shape, which I'll then be able to use to extrude to subtract the material. All I need to do now is dimension from the end of that line, so getting that wee green dot, to the top of the object to 30 millimeters, finish the sketch, and then I can use extrude to subtract. Now, at the moment it's only going one direction, so I want to use the symmetric constraint, if you like, so that it goes through the object from the centre and equally distanced to 50 will do. It's clearly more than enough, though you could just bring it down to your diameter of 20 if you wanted to, and then that would be fine. It would still do the same thing, or as long as it's going through the whole object, that's okay. Obviously you can see if it's less than that, it's not going to chop off all the slope that you need, so you just need to make sure it goes beyond the object. There you can see that we've done an extrude to subtract in a slightly different way than we did in the previous example, just using a work plane this time instead. We're now looking at revolve, and to give you an example of a revolve question, we're looking at 2018 National 5 paper question 4, part C. So we've got little rubber feet here, as you can see in the question, and to work out that we're using revolve here, I've used the flowchart and I've worked out that it's not a uniform cross section. It's not just a cylinder the whole way up. We've got the step out here, a chamfer, and two different diameters for these holes in the middle. So for that reason, I'm going to use revolve. I've also obviously got a centre line through it, so I know that it's circular or circular based. So to do this, we're going to start by drawing a sketch. Again, doesn't matter which we're going to go for. And the first thing I'm going to do is I'm going to draw the centre line. So I can see from the drawing here that the height of the object is 13 millimeters. So from the centre of these lines crossing, I'm going to draw a line that is 13 millimeters tall. At this point, I'm going to click the line and I'm going to turn it into a centre line. Okay, that's really helpful when you're doing a revolve, because when you use the revolve command later on, it'll automatically pick up your centre axis and you won't have to select that at that point. What I'm going to do now is I'm going to draw the basic outline shape of the profile. Okay, so from roughly about, well, in line with the end of the line there, I'm going to go straight down, out, straight down to the bottom, out like that, up for the chamfer, straight up, back in, up and across. At this point, it doesn't matter what size these are. I'm going to use the dimension tool now to put all the sizes in. Now, because I've got a centre line here, when I click that centre line to dimension to this edge, it's going to come up as a diameter. Okay, so it's a diameter of 4 for that part. I've then got the diameter of 12 out to that part, and the diameter of 16 out to the total diameter of the object. We've then got the diameter of the hole here at 8, and then the diameter to the point where the chamfer goes up at 16 as well. Sorry, 12. Okay, now I'm going to do some vertical heights on this. So I know that the height of this hole here is 3 millimeters. The height of this vertical part here is 7. And the height of this part here is 4. Now you can see here, well, putting that 4 back in has brought that back up in line, but if for any reason it hadn't done that, I could have done this. If I delete that and use the dimension tool to dimension between vertical edge there, sorry, horizontal edge there and the end of the line, and dimension that to 0, that will bring that up. This you can then fix to being the 4 millimeters. Then what we should find is that this is the correct chamfer, just based on the other dimensions that we've got. So once I've got all the dimensions in, we can then finish the sketch, use revolve, and like I say, because you've already got that as a centre line, it picks that up as our centre axis and then revolves the profile. In this case, we're going 360 degrees. You can change that if you wanted to, depending on the object. It might be that you only need to revolve it 3/4 of the way round, 270 degrees, or maybe halfway, or any angle that you might need to revolve something to around 360 degrees, but obviously it was going the whole way around, it's 360. So that is revolve. For extrude along a path, we are going to look at higher paper from 2015, and it's question 1b, looking at creating this pipe section of the fire extinguisher. So, two things that we need for our extrude along a path. One is the profile and one is the path. So the profile is the shape of the object, and then the path is the way it's being extruded. Okay, so we're going to start a sketch on one of these work planes. I'm going to do the profile first. So what we can see from this is we've got hidden detail going along the path of the pipe here, outside diameter of 10, inside diameter of 7. So that's what I'm going to draw first. Outside diameter of 10, inside diameter of 7. There's our profile. What we need to do now is our path. And the path, and this is the way you have to, do the modelling technique, but also explain how you would do it in an exam question, is on a perpendicular, at right angles, perpendicular work plane, we need to do the path. So in this case, it's perpendicular to these circles, so it has to be this X, Y, or well, it could be either, but I'm going to do it on the XY plane. So from that centre point, I'm going to draw the path that I need to follow here. So I'm going to draw a line going straight out, and the length of that line is 66 millimeters. I then have an arc with a radius of 51. So what I'm going to do is I'm going to draw the circle. Now that's the diameter, so the diameter of this radius, thinking tangency, would be 102. It's in line with the end of that, so I should be able to dimension from the centre of the circle to the end of the line, and I think it is in line with it already, so that's fine. So I'll go tangent and make that circle a tangent to that line. I've then got the arc coming round to and finishing at 60 degrees. So what I want to do here is draw a line out to the circumference. What I'll also need is a vertical line here, so that I can dimension between that line and that line to 60 degrees. And then I can use the trim tool to remove the bits of the circle I don't need. What I might also need to do here is turn these two lines by selecting them both into construction. And then I'm using a line to continue off there at a tangent. Now you can see it kind of snaps in at that point. And the length of this line is 62, so I'm just going to type that in now, otherwise I won't get the right size later on. That's the path completed. I can then finish the sketch and then use, Inventor calls it sweep, but it's extrude along a path to pick the profile and the path. Click OK, and there we have extrude along a path. To look at our sort of more straightforward loft, we're looking at question 1b part 1 from the 2019 higher paper. So what you can see here, and this is why we've got to use loft, is we've got a square shape at the top of the object going to a round shape further down. And I'm going to start with the loft part of this. So I'm going to start a sketch on a surface. I'm going to start with the circular part, just because it's a little bit more straightforward, and the diameter of that is 105. Okay, so finish that sketch, and now what I need to do, and this is the terminology we need to use for lofts, is to offset a work plane. So I'm using the plane tool, finding the plane that I've drawn that circle on, clicking and dragging and changing that size to the right size there, which is 110. Okay, so I've got the 110 offset from the original circle. On that surface or work plane that I've just drawn, I'm going to draw my square 50 profile. So dimension that to 50, dimension that to 50, and then just make sure that it is in the centre of that surface, like so. I can then finish the sketch and loft between the two. So use the loft command, picking the first profile, picking the second profile, and clicking OK. I'm going to continue with this model just so you can see how you would continue on to complete it. And at this point we need to shell the object just to make sure that the section on the bottom works correctly. So we can work out from the working drawing that the wall thickness is 4mm, so I need to use the shell command, set the wall thickness to 4, and then just make sure that I'm removing this bottom face here. Then I'm clicking OK. So then on the bottom of that, I would start a new sketch. I could just project the geometry of those two circles, save me a bit of time, finish the sketch, and then extrude that ring there to 10mm. Start the sketch on the bottom section there. This time I just need to project the geometry from the internal circle. It's splitting into 4 here because it lofts further up, so I'm just going to select all 4 of those sections. If this was an exam question, you wouldn't have to describe it like that. It's just a nuance of Inventor here. But you're just drawing a circle with the right diameter. And then we're drawing the outside diameter circle, which is 113. Finishing the sketch and extruding that new ring there to a depth of 4. And that is that component complete. Another feature within a loft is what we call rails. Now, normally these happen automatically. The computer will automatically extrapolate the shape that it's going to create when it does a loft. But you can direct a loft in the direction that you want it to go, and when you direct these direction lines are called rails. So to give an example of this, we're looking at the specimen question paper, and it is question 2A part 1 for the most part. So what we can see here is we've got 2 square sections, but it twists as it goes up. It twists at 90 degrees. So to do this, what we need to do is start a sketch as we would with a loft. I'm going to just draw from that corner, and it is 40 square. So 40 and 40. Finish that sketch and then offset our work plane like we would normally. So find the work plane that's drawn on, click and drag, and it is offset 120mm. On that work plane now, I'm going to draw another circle, square even, where that is 40 square. Okay, so 40 and 40. What I can do now is create work planes between the sort of edges or the surfaces of this loft so that I can draw my rails on it. So to do that, I'm going to use the work plane tool, click that line and then click that line. You can see I've got a work plane going vertically between them now. I'm going to start a sketch on that new work plane, and I'm going to go pictorial so you can see this, project the geometry, but just of the end corner there to that opposite one, just so it's got something to snap to and I know it's going to work. So then I'm just drawing a line between that point and that point. So you can see that that corner now connects to the corner 90 degrees from it on that offset work plane, if that makes sense. So what I'm going to do now is work plane on that surface, start a sketch on it, and I'm going to go pictorial so I can keep track of what ones I'm doing. Project the geometry from that corner and that corner, and then draw the lines between. And work my way around so that I've done that on all 4 surfaces. Now, if this was an exam question, you wouldn't have to describe all of this the way I'm doing it just now. You would just simply say that you're creating the rails and perhaps do some sort of little sketch to suggest the shape that you're making. It is a bit of a tricky one, even if you draw the 2 squares first and then join up opposing corners or 90 degree corners, whatever you want to call them. then and that will give you basically the shape that you're looking for. But like I say, you don't have to do and describe all of these individual steps of doing each surface, joining up the corners. You would just do it in one straightforward move so that it's nice and concise for anyone who's marking it. So that gives us the rails to follow. So I've got my two profiles and the rails. What I would now do is use the loft command to first of all select the profiles, and then over here it gives us the option for rails. So click to add, I'm going to click that bit, and then I'm going to click the 4 rails that I've drawn. When I click OK, you'll see that the surface twists as it moves up on that loft. Okay, so that is how you would do a loft with rails. To create a helix, we're looking at 2017 paper question 1C. Now, in this example, the helix is a spring. It's part of the suspension system of a bike, but it would be worth pointing out that a helix can be, the profile can be any shape. It's still going to be this helical shape, the sort of spring shape, but it doesn't need to be a circle. It could be elliptical, it could be U-shaped, it could be any shape that you're bringing round that centre axis. So to do this, we need to first of all create our profile. So I'm going to just start a sketch. I'm then going to draw a line to represent a centre. Now in this example there is no length to this. What we've got is we've got our pitch, and then we can count the number of revolutions. So all I'm doing at this point is drawing a short line and making it a centre. What I'm then going to do is draw the profile. So it's in line with the top of this. It has a diameter of 10, and then the overall diameter of the helix is 80 to the centre of that circle, or the profile. So that's me got my centre axis and my profile. I would then finish the sketch and use the helix command. Now in Inventor it's called coil, but we always use helix, and it will do certain things by default. So you can see it's going up the way, but if I'm starting at the top, I maybe want to go this down the way, so I'm going to flip the axis. I then know that the number of revolution, well, I need to change the options here. So it's rather than revolution and height, I'm going to do pitch and revolution. So I can count from this that I've got 1, 2, 3, 4, 5, 6, 7, 8 revolutions with a pitch of 40. So by putting those sizes in and then clicking OK, you can see that I have created the helix more or less as you see it in the exam question.